All right, you guys ready to get a little bit trickier here? So just at a glance, I think you can tell that these two examples look trickier than what we just did. But just know that we're going to follow the same process. We're going to manipulate the equations so they have the same base, and then we can set the exponents equal to each other. That's essentially what we're doing. Okay, so let's look at this first equation and focus on this 1 over 125. So 125 is the same thing as 5 to the third power. That is 125. So that's 1 over 5 to the third power. Well, I don't really want to work with that fraction, so I'm going to move that 5 to the third power to the numerator. That movement will change the sign of your exponent. This is part of our negative exponent properties. So that's going to be 5 to the negative 3 power. That is the same thing as 1 over 125. So I replaced the 1 over 125 with 5 to the negative 3 power. I'm going to carry down that exponent is negative x over 2 equals. All right, so let's look at the other side. Same idea, we can see we have 1 over 25. We know that 5 squared is equal to 25. So we can rewrite that fraction as 1 over 5 squared. Well, we're going to move that 5 squared to the numerator so we don't have to deal with a fraction. Remember, we like this. This is a good move. But that will change the sign of your exponent. So that is going to become 5 to the negative 2 power. So 5 to the negative 2 power is the same thing as 1 over 25. So we just replaced that with 5 to the negative 2 power. I'm going to carry down the exponent that is with that. We have a negative x over 3 minus 2. Okay, we're going to clean this up a little bit. When we have a power to a power, we multiply exponents. Keep your base of 5. Negative 3 times negative x over 2. The negative times the negative is positive, and that's going to give us 3x over 2. It's like negative 3 over 1 times negative x over 2. All we did was multiply the numerators and multiply the denominators. All right, that's equal to, over here we're going to multiply our exponents, but we have to multiply the negative 2 to this term and to this term. We're just going to do some distributing here. So negative 2 times negative x over 3, negative times negative is positive. Keep our base of 5, I forgot to write that part down. That gives us a positive 2x over 3. And then negative 2 times negative 2 is a positive 4. All right, we did some beautiful manipulating here. We have the same base. 5 to a power equals 5 to a power. So that means your powers, your exponents, will be equal to each other. And that's where the x is, so that's the one we care about. 3x over 2 is going to equal 2x over 3 plus 4. All right, so we might not like the fact that there are fractions in our equation. We haven't done this in a while, but we've got this great fraction trick. If we multiply every term by the common denominator, we have a 2 and a 3. A common denominator is going to give us 6. If we multiply every term by a 6, that will eliminate our fractions. So 6 times 3x is 18x. 18x divided by 2 is 9x. No more fraction. 6 times 2x is 12x. 12x divided by 3 is 4x. Got rid of that fraction. And then to keep it balanced, we also have to multiply the 6 times the 4. That's not a fraction, so that's just 6 times 4, which is a positive 24. And now we solve. Let's get the x's to the same side. We're going to subtract 4x from both sides. So we get 5x equals 24. Divide both sides by 5. And our final answer for x. 24 does not divide by 5. So we'll just leave it as 24/5. It doesn't reduce, so we like that answer. Okay, one down, one to go. So this one is going to be the same idea. we're going to manipulate how it looks so that we can use our exponent properties to solve. So we have, let's see, 1 over 8 and 1 over 4. I can't rewrite 8 as a power of 4, like 4 to the second power is 16, but I can rewrite both of these as powers of 2. So here's how that's going to look. We're going to rewrite 1 over 8. 2 to the third power is equal to 8. So 1 over 8 is the same thing as 1 over 2 to the third power. We don't want to work with that fraction, so let's move that to the numerator. That's going to give us 2 to the negative third power. That's the same thing as 1 over 8. And then I'm just going to carry down the exponent, x over 2 minus 1. Equals, now this 1 over 4, 2 to the second power is equal to 4. So I'm just going to replace the 4, 1 over 2 squared. We don't want that in the numerator. We want it in the we don't want that in the denominator, so we move it up, changes the sign. It's going to become 2 to the negative 2, and then carry down our exponent of x over 3. So we're getting closer. I can see that we have bases of 2. We just have to clean up our exponents over here. When you have your power to a power, we multiply exponents. So this negative 3 is going to multiply to both terms of that exponent. You keep your base, 2. Negative 3 times x over 2 is a negative 3x over 2. And then negative 3 times negative 1 is a positive 3. Equals, keep your base of 2 on this side and multiply negative 2 times x over 3 is a negative 2x over 3. Well, there we go. We got our same base, which means the exponents will be the same, so we set them equal to each other. Negative 3x over 2 plus 3 will be equal to negative 2x over 3. Solve for x. All right, so solving for x, we have fractions. Let's get rid of those. Multiply every single term by a common denominator. Common denominator between 2 and 3 is 6, so kind of similar to the last problem. Let's multiply every term by the 6. So 6 times negative 3x is negative 18x. Negative 18 divided by 2 is a negative 9x. 6 times a positive 3 is a positive 18. 6 times negative 2x is negative 12x. Divided by 3 is negative 4x. Now we've got something we can solve. We will add 9x to both sides just to get those x's on the same side. 18 is equal to a positive 5x. Let's go ahead and solve for x by dividing by 5. We got x alone. It equals 18 over 5. 18 does not divide by 5 evenly, and it doesn't reduce, so we'll just keep that 18 over 5 answer.